You believe the universe follows rules. You trust that gravity pulls, atoms bond, light travels. You assume tomorrow's physics will match today's. This assumption is wrong. The laws governing reality exist in a state physicists call metastability. Our universe balances on a knife edge. One quantum event could erase everything that ever existed or ever will exist. No warning, no survivors, no aftermath. Think of our cosmos as that droplet. Surface tension maintains its shape, but this is not true stability. This is borrowed time. The water wants to fall. Physics wants to collapse. We inhabit what theorists term a false vacuum, a temporary minimum in the energy landscape of the Higgs field. The universe you know is a placeholder waiting for deletion. Come on, Mr. Satire. Every civilization believes its moment is permanent. Romans thought their empire eternal. We think our physics fundamental. Both delusions spring from the same cognitive failure. Humans mistake stability for permanence. Your universe exists in a local energy minimum, not the lowest state possible, just a dimple in the cosmic energy landscape where matter temporarily congregates. Physicists discovered this uncomfortable truth when measuring the Higgs boson mass at CERN. The number came back wrong, not incorrect, wrong in a specific, terrifying way. The Higgs field permeates all space. It gives particles their mass through interaction. But this field has an energy configuration. Physicists map this configuration as a potential landscape. Picture a Mexican hat. And, later, the brim represents high energy states. The trough where you'd rest the hat on your head represents lower energy. Our universe sits in that trough. Comfortable, stable enough for galaxies, stars, biology. But the mathematics revealed something else. And, press it, blue mark. A deeper trough exists. A true vacuum with lower energy. Our false vacuum wants to roll downhill into that state. Quantum mechanics provides the mechanism. The Higgs field value in our universe sits at 246 giga-electron volts. This number determines particle masses. Change this value, and electrons gain different mass. Protons become unstable. Atomic bonds dissolve. Chemistry becomes impossible. Life becomes impossible. The current value allows our existence, but this value occupies a local minimum in the scalar potential. Imagine a ball in a shallow bowl on a hillside, stable until something nudges it over the rim. Then gravity takes over. The ball rolls to the true minimum at the valley floor. The energy difference between our false vacuum and the true vacuum may seem small on particle physics scales, perhaps 10 to 30 gigaelectron volts per cubic meter. But multiply this across the observable universe. The total energy differential exceeds the mass energy of all baryonic matter by factors of millions. Our universe stores potential energy like a compressed spring. Classical physics says the ball needs enough kinetic energy to climb out of the bowl. Roll it toward the rim without sufficient speed, and it falls back. But quantum mechanics rewrites these rules. Particles do not obey classical boundaries. Quantum tunneling allows particles to pass through energy barriers they classically cannot surmount. Heisenberg's uncertainty principle permits temporary energy violations. A particle borrows energy from the vacuum, crosses the forbidden zone, returns the energy on the other side. This happens constantly at subatomic scales. Radioactive decay depends on it. Semiconductors exploit it. The sun's fusion requires it. Now apply this mechanism to the Higgs field itself. At any point in space, quantum fluctuations occur. The field value oscillates. Most oscillations stay small, thermal noise in the cosmic background. But probability allows for larger fluctuations. A bubble of true vacuum can spontaneously form through quantum tunneling. The Higgs field in a small region suddenly jumps to the lower energy state. This creates a boundary, a membrane between two vacuum states, the false vacuum outside, the true vacuum inside. Surface tension at this boundary provides energy, but the volume inside releases energy by dropping to the lower state. For small bubbles, surface energy dominates. The bubble collapses. For large bubbles, volume energy dominates. The bubble expands. Physics determines a critical radius. Form a bubble larger than this threshold, and expansion becomes inevitable. Unstoppable. Coleman and DeLucia calculated the tunneling probability in 1980. The rate depends on the barrier height and width in the Higgs potential. Their equations yield unimaginably small numbers. But perhaps one bubble forms per 10 to the power of 200 cubic light years per year. Our observable universe contains about 10 to the power of 80 cubic light years. These odds seem comforting, but infinity has no mercy. Given infinite time and infinite space, all probabilities approach certainty. The universe has existed 13.8 billion years. It extends far beyond our observable horizon. Somewhere, sometime, the critical bubble may already have formed. The bubble expands at light speed. Special relativity guarantees this. The boundary moves at c. No information can travel faster. No warning can outrun it. You cannot see it coming. The bubble's interior obeys different physics. The Higgs field value differs. Particle masses change. Fundamental constants shift. The electromagnetic force strengthens or weakens. The strong nuclear force may lose its ability to bind quarks. And atoms, as you know them, cannot exist in the true vacuum. Chemistry stops. Biology stops. Thought stops. Special relativity provides one mercy. You won't suffer. The boundary travels at light speed. Light from the boundary cannot reach you before the boundary itself arrives. Your last moment appears normal. Stars shine. Air moves. Neurons fire. Then the boundary passes. Every atom in your body simultaneously ceases to obey chemistry. Electrons unbind from nuclei. Molecular bonds rupture. Your constituent particles disperse at relativistic speeds. No pain, no awareness of transition. One moment you exist. The next moment the concept of you becomes physically impossible in that region of space-time. Inside the true vacuum, physics operates under rewritten rules. The exact changes depend on which minimum the Higgs field reaches. Multiple true vacuum candidates exist in the theoretical landscape. Some scenarios permit new stable configurations. Atoms might form with radically different properties. Elements as you know them disappear. New periodic tables emerge. But organic chemistry likely becomes impossible. Carbon's bonding versatility depends on precise mass ratios between electrons and quarks. Change those ratios, and carbon becomes inert or unstable. Silicon, nitrogen, oxygen all lose their biological utility. Gravity itself may change. Einstein's field equations contain the cosmological constant. This term depends on vacuum energy density. Change the vacuum state, and space-time curvature changes. Black holes formed in the false vacuum may evaporate instantly in the true vacuum, or they may grow without bound. Neutron stars might exceed stability limits and collapse, or they might expand as nuclear binding energy shifts. 1 meter, 18. Every gravitational structure in the cosmos exists because current physics allows it. Rewrite physics, and every structure becomes a temporary fossil, awaiting dissolution. Is it happening now? Has the critical bubble already formed beyond our cosmic horizon? Light from sufficiently distant regions hasn't reached us yet. A bubble forming 20 billion light-years away would take 20 billion years to arrive. Our universe is only 13.8 billion years old. An expanding true vacuum bubble could be racing toward us right now. We would see nothing until the last instant. Physicists calculate the expected lifetime of our false vacuum. The probability equations depend on precise measurements. The Higgs boson mass at 125 GeV, the top quark mass at 173 GeV. These measurements place our universe in the metastable region. Not stable, not immediately unstable. Metastable, The false vacuum will decay eventually, but eventually might mean 10 to the power of 100 years, 10 to the power of 500 years. Numbers that dwarf the current age of the universe by factors incomprehensible. Heat death would arrive first. Protons would decay first. Black holes would evaporate first. The expected tunneling time scale exceeds every other cosmic process by unimaginable margins. Yet probability offers no guarantees. The next bubble could form in your lifetime, in the next hour, in the next second. Physicists worldwide monitor high-energy particle interactions. CERN's Large Hadron Collider smashes protons at energies approaching conditions moments after the Big Bang. Some theorists worried these collisions might nucleate a true vacuum bubble. Well, if you want to prove any large bee or box or any large kit ball, the food is amiss. Some theorists worried. The math shows this incredibly unlikely. Cosmic rays strike Earth's atmosphere with far higher energies. For billions of years, if such collisions could trigger decay, it would have happened already. The universe has tested itself far more violently than any human experiment. Still, caution persists. Each new particle accelerator proposal triggers stability calculations. Each measurement refines our position in the parameter space. And, for more, the false vacuum will fall, maybe tomorrow, maybe in 10,000 years. Certainty provides no comfort, but neither does uncertainty. Your universe exists on borrowed time. Every atom temporary, every law provisional, every moment unstable. This should terrify. Instead, consider it liberation. Meaning exists because existence remains finite. Beauty emerges from fragility. You experience wonder precisely because wonder might end. The fundamental constants that permit your consciousness could have taken infinite other values. They happen to align in this narrow range, allowing chemistry, stars, planets, life, thought. The universe will continue after you, after humanity, after Earth, after the Sun. But it will not continue forever in its current form. Physics itself evolves on cosmological timescales. The Higgs field will find its true minimum. The waiting game resolves eventually toward the only stable configuration. Until then, you inhabit a cosmic anomaly, a temporary excursion into complexity between two simple states. Before you, the random quantum foam, cryostructure. After you, the true vacuum, where complexity becomes impossible. In between, this moment, this thought, this awareness of the precipice, the false vacuum grants you brief consciousness before the fall. What you do with this moment defines whether that consciousness mattered. Physics does not care, but you do. That distinction contains everything.